This is section 811. We're going to take a look at angles and radians. So we're going to define an angle, examine an angle measure, draw angles in standard position, and define radian measure. So going over what an angle is, we start with a ray. And a ray is basically half a line. It has an initial point, and it goes on forever in one direction. Now, if we were to take two of them and put them together, that's going to create an angle, and where they meet, we call that the vertex. Now, you can have an angle that's a straight line. You can also have an angle where the rays are basically the same thing. That means that it's implying that it's rotated all the way around. Now, the measure of an angle is essentially the amount of rotation that separates those two rays. There's an issue though. If I were to say, hey, I have two rays here, what is the angle of separation between them? Do I mean that angle, or do I mean this angle of rotation, right? Because this can rotate all the way around this way. So which one am I talking about? Well, we give them names. And by giving them names, in this case, angle alpha and angle beta, what ends up happening is now it removes that ambiguity. Now, there's still a little ambiguity, though, in the fact that, well, am I rotating this way or am I rotating this way? And that's something that we're going to address a little later. Now, some commonly known measures of angles is if we go all the way around and it ends where it starts, we would say that that's one revolution or 360 degrees. If we rotate to where it creates a straight line, that's 180 degrees. And then we've seen this one before. If we rotate and it kind of creates that L shape, we would say that it's going to be 90 degrees. Now, a relationship between these angles is if an angle is between 0 and 90, we would say that it's an acute angle. If it's between 90 and 180, it's an obtuse angle. And if two angles add together to equal 90 degrees, we call them complementary angles. And if two angles add together equal 180 degrees, we call them supplementary angles. Now, I had mentioned that there is that level of ambiguity, right? Like, how do I rotate, right? Did I rotate this way or did I rotate that way? Well, to do that, what we do is we actually name the rotation itself. So if we go clock or counterclockwise, we would say that that's a positive rotation. And if we go clockwise, that's going to be a negative rotation. So if I started here at my initial side and I rotated this way, that's a positive rotation. If I started here and I rotated this way, that's going to be a negative rotation. Now, we use this thing called standard position to help us with drawing our angles. And so essentially what we do is we take the vertex, we want the vertex to be along the origin, and we say the initial side is along the positive x-axis. And what that actually allows us to do is it not only allows us to draw angles much easier, but it actually gives the angles a little bit of meaning. We can now classify these angles based upon where this terminal side is going to be. So this is going to be an angle that's in quadrant 3. That has meaning to it. So let's practice kind of drawing these. So I'm going to draw 135 degrees in standard position. So we kind of draw it. I know that each of these is 90 degrees, and so that's why I'm doing that. So there's my initial side. So if I have 135, if I go this much, okay, that's 90 degrees, so I have 45 left. Well, 45 is half of 90 degrees, so I'm going to cut that in half. So there's my rotation. There's 135 degrees. Now, I rotated this way because it's positive rotation. It's a positive 135 degrees. Now this next one, it says negative 200. So I need to rotate in the negative direction. So the initial side is always going to be up on the positive x-axis. I know that if I rotate this much, okay, that's 90. Okay, so that's going to be 110 left. If I rotate that much, that's another 90. Okay, so I'm going to have negative 20 left. Okay, now I need to cut this up. Okay, so 45 is half of 90 degrees. Now if I cut 45 in half, that's about 22.2, but that's pretty close. So if I almost go there, that should give me about the 20 degrees. Now notice I went clockwise, which is rotating in the negative direction. Now the last thing we're going to talk about is radians. Now just like we have feet and yards and miles and centimeters and inches and meters, all of these measure distance, right, between 2 points. Well, an angle is essentially a measure of rotation. When we say degrees, that is a unit that measures rotation. Well, a radian is going to be just like feet, yards, miles, how they all measure distance. A radian is just another unit that measures rotation. And we've already actually seen radians a little bit. We just didn't realize. And if we think of our circumference circle, right, like 2 pi r, remember the circumference is, if I have a circle, it's the distance around the circle. Okay, well, r stands for how far we go out, but where did the 2 pi come from? Well, 2 pi is actually the rotation around the entire circle. It's like saying 360 degrees. So this part right here was the radians, and then this part right here is how far you go out. Interesting, right? So we've already seen it. Now, 2 pi equals 360. Now, if I know that 2 pi equals 360, well, that means 180 degrees is going to be pi, right? If I cut 2 pi in half, that just gives me pi. And so each of these halves of my circle are just going to be pi. Pi plus pi gives me that 2 pi. Well, I can actually cut this up even further, right? I could actually cut this in half. So if I wanted to cut that in half, I get pi halves. So if we're thinking of this being pi, and I cut that in half, well, then I get pi halves. So pi halves plus pi halves is pi. Plus another 2 pi halves is another pi. Add them together, you get 2 pi. And I could cut this even further. I could cut this pi half in half. And if I cut the pi half in half, that's going to be a fourth. And so I can go through the entire circle and cut it into fourths. I can do the same thing with thirds. I could cut this pi into thirds, so 3 even slices, and I can do that around the entire circle. And you can cut it up into 6, and then obviously our 2 pi is going to be the 360 degrees. Now, this is just what we're just remember, it's what you're cutting half the circle. What you're cutting half the circle. So let's draw 4 pi thirds in standard position. So I just draw this because it helps me. Okay, I'm going to cut half the circle into what? Thirds. So I'm going to cut that into 3 even slices. Now sometimes if it kind of confuses you and throws you off, like just get rid of this because you don't need it anymore. And so now we count. 1, 2, 3, 4. There's my 4 pi thirds. Now it was positive 4 pi thirds, so I rotated in the positive direction. Now what if this said, I'm just going to write it, I'm going to add a negative there. What if that said negative 4 pi 6? Okay, so we draw our, so that means that I need to cut half the circle into 6. Okay, so that means I'm going to cut each of these into thirds. Okay, so we start there. 1, 2, 3, 4. And there's 4 pi 6. Now, it was negative, so I rotated in the negative direction. So what did we learn today? We learned to define an angle, examine angle measure, we drew angles in standard position, and we looked at some radian measuring. Now, what's the difference between an obtuse and an acute angle? An obtuse angle is between 90 and 180, and then an acute angle is between 0 and 90 degrees. And how many slices does the circle get if it's cut by pi force? Now, I know you may be thinking, that pi force means what we call half a circle, so you might be thinking 4. But remember, we have to cut the entire thing, so we'd actually get 1, 2, 3, 4, 5, 6, 7, 8. This does conclude our lesson. If you have any other questions, please leave them in the comments.